Alright, so for this experiment, this is for Planck's constant. So what we have here is, this is the mercury source. So plug this into the power supply, and then there is a switch here. And it has written Hg, that means it is for the mercury. So turn it on. It takes a while to give the light from mercury. Okay, so it's like a mercury vapor. It takes some time to vaporize, and then only it gives the light from mercury. So in front of here, this part is the grating and lens. So if you move back and forth, you'll see the lights are focused at different points. So since it's a grating, light coming from here will have different order of the lights. So it depends on what's the color we have. So now let's look at here. Okay. So if you turn off the light and then come and see here. Come and see here. So this one is a direct beam, and then you see first order, right? First order blue, purple, green, yellow, red, and then again you'll see the another second order blues, green, yellow, right? So you'll also see the same thing on this side. First order. So and then a second order here. If you turn off the light outside, then we can see this clearly. Okay, so this is first order, and the second orders are here. So we are not seeing the second order very carefully. All right. Okay, so these lights, what are the wavelength of these lights? These are written here in your manual. So yellow color is 578, green is 546, blue is 438, right? Violet is 404, ultraviolet is 365. So it goes like this. Now you can rotate this, right? And choose whichever color you like. So if you put here, this is direct, right? Direct means it has all the light. So if you choose here, so there are three in the blue region. Turn off that. There are three here. So one is blue, one is violet, and another is ultraviolet. Okay, so then rotate this to enclose one of them. Yeah, let's say I'm going to use green, right? Green. So turn it on, and make sure once you put the lights on, you can rotate this tube, and then light has to incident on the photocell inside. There is a photocell inside. So if it doesn't incident on that, you have to adjust a little bit, and also move this lens a little bit. I think this is fine. Okay, so once it is ready, then close this tube again. Now next is to measure the voltage. So it's like it's a photoelectric effect. Once the light incident on the photocell, it gives the electron beam and a photoelectron. And the way it measures the maximum kinetic energy of the photoelectron is by charging a capacitor. This is the technique used here. You can see the circuit here. So connect this output to the voltmeter, right? Voltmeter, and then the voltage will be very small. So So put that here in the 20 volt voltage and comma 20 volt range. So what do you do? First, before you take the measurement, push here to 0. You have to make it 0. That means you are discharging the capacitor. Now turn this on. Once you turn it on, you will see the capacitor voltage. Turn off the light. Okay, turn on the light. Okay, now capacitor voltage is 0.91. So that's kind of stopping potential. Okay, so once you take the reading, before you take the another reading, you have to make sure push this to 0, discharging the capacitor. So now then move to another color and so on for the first order and the second order. I think that's the second part of the experiment. And it is also first part of the experiment. What you have to do is you have to use this. This is called a density filter. So if you put here, if you put the extreme right, that is 100% transparent. And next is 80% transparent, 60%, 40%, and 20%. So you can move this, right, at different point. So what you are doing is changing the intensity of the light, but for the same color means same frequency or same wavelength, and see what happens. So two parameters here. One is choose particular wavelength and vary the intensity, and another is vary the wavelength. So you need to rotate this and use the different color for the different wavelength. You need to use this with a particular color to change the intensity. So after that, once you have the data for different colors and fill up the there's a table, then we have to plot the graph, and from that graph you can find out the Planck's constant. All right. Okay. Good luck.